So when we're talking about data bias, we have to talk about data that has been biased historically. So let me explain what I mean. So here's our familiar 6-question framework for exploring questions in the ethics of artificial intelligence. Just so you know, I'm going to skip over question 3 for this particular problem because I'm not sure. I mean, it seems like the new things to me are because of the capabilities of digital technology, not the scale. And skip over 5 as well because the answer is very easy. The ethical value is fairness. Because if something's biased, that means it's not fair, simply speaking. All right, so what is a description of this problem? Okay, the important thing to think here is that we're talking about accurate data. So another video on data bias I had is about data that's not representative. When we're talking about data that's not representative, when it claims to represent something or when it should represent something that it doesn't, that data is essentially inaccurate. Here, we're talking about something very different. This is a very different problem with very different potential solutions. In this context, I'm actually more skeptical. In the non-representative, I'm a little more optimistic about it. But this is data that is biased even though it's accurate, or rather, because it's accurate. So the story is that the data accurately captures all the structural unfairness, oppression, biases that we have in society. It's just taking a snapshot of that and telling us about the unfairness. So the question is, how should we handle data that is historically biased? So let's think about what's familiar about this problem. And what's familiar is, okay, so anytime we have a data set, this is very, very common. We have a data set that shows a discrepancy between two groups. Use your imagination, lots of different kinds of discrepancies between groups exist. Group A has, is making more money than group B or something like that, right? Okay, so when we're confronted with that, we have to agree that the data is accurate, but let's say that we have made that agreement, we agree that the data is accurate. Then there's the question, what is that telling us? And there's, generally speaking, 2 possibilities. One is you could think the data is telling us something about that group, that something about their natural capabilities or whatever somehow, right? Or you can think that the data is telling us something about injustice, the society that group lives in, telling us something about the social injustice of it, right? So this is a very classic fight in social justice. There's the fact, but then there's 2 ways to interpret the fact. You could say, it's telling you about the group, or you can say it's telling you about the way society is structured. So, for example, the data will tell you that at the executive level of business, there's more males than females. Okay, so what's that telling you? Well, it's possible to think that's telling you something about females, about can females, business leadership potential. But the true story, of course, doesn't tell us anything about what women can do. It tells us about how society is structured and that there are barriers to women being in business. Okay, so what is new about this problem because of the capabilities of a digital technology? So I've referenced the non-representative data thing, and I want to bring it up again. Here, it's a little bit different because it's not that the data can be in non-representative data, data that claims to be representative, data that's used in inferential statistics, is used to estimate population parameters. And the data is not used for that. So we're not talking about inferential statistics anymore. But the other side of that, which is that what is the data used for? It's used to create models that make predictions. So the danger there is that the predictions will reinforce their own biases by becoming self-fulfilling prophecies. So that problem that we talked about before, it's still there, it's still present, it's still a very important problem to worry about. Let me focus on another problem that doesn't occur with non-representative data. I guess it can, but it's more likely to occur here. So you might think that we could solve the problem of historically biased data with feature selection. Okay, so here is a a small data set, what data looks like. So you might want to say, okay, we're going to feed this data to the algorithm, but we don't want the algorithm to pick up the biases of the data, right? For example, we don't want the algorithm to get confused that the data is telling us that women are somehow not as good at business. Like we don't want the algorithm to make that mistake. So what should we do? We can eliminate the gender variable, or we can eliminate the race variable, or whatever variable that you're concerned with that's creating the problem, is showing the structural bias. So before you feed this to an algorithm, you might think, okay, let's just take out column C, column E, whatever other columns are telling us about this identity, and then the algorithm gets a hold of this data and makes its conclusions, and the algorithm can't possibly be racist or sexist or whateverist because the algorithm just didn't have that information. Seems like a reasonable solution. However, that is not how it works, or at least that's not always how it works. So algorithms are able to figure out that those kinds of identities through proxies. Okay? So these are essentially correlations that it makes between different columns of the data. So it's not explicitly told that, hey, this person in this row is a female, but it can figure that out by looking at the other data and how the other data is similar to other entries. Okay, so we could call this the problem of proxies, but essentially, as soon as the simple solution, well, we'll just X out that feature, and so the system will never know that this is a female, and so they'll never become biased against females. That's not right because of the problem of proxies. And let me illustrate this and talk about. As I said before, I'm skeptical here about potential solutions. And let me just give you an example about why I'm skeptical. So there's a famous example where Amazon tried to develop its own hiring algorithm, right? And so you can see how this would be very useful for Amazon. They hire, I don't know, hundreds of thousands maybe, I don't know, tens of thousands of people, or at least that's how many applications they get. And so, it'd be very useful if there was an algorithm that could just filter through the applications and then just select a few for the hiring manager to read instead of having to sift through thousands and thousands of applications, right? So Amazon was trying to develop this hiring algorithm. It turns out the project got scrapped. So there are not a lot of details released, but I'm just wondering what we can infer from the problem getting scrapped. So Amazon has a lot of extremely talented people, right? And so you got to think that if they're developing this thing that's going to save them, it's going to create so much efficiency in their business, they're going to have like some of their best people working on it, right? You also, what we also know about Amazon is they have, all the resources in the world. And so they had tons and tons of resources to throw at this, tons and tons of talent to throw at this, but they didn't make this hiring algorithm because they couldn't figure out how to make a hiring algorithm that wasn't biased against women. So, again, I don't know the details of this. I'm not saying this is what happened, but we can kind of fill in the gaps. Like in a similar situation, here's something that could have happened. So you deselect the feature, the gender variable, and so the system doesn't know what gender the applicant is. However, the system starts to make correlations and inferences. For example, maybe it started to detect that people who were in the Women in Business Club were less likely to succeed at the corporate level, right? So the algorithm doesn't know why this is true. It's just making these correlations and then spitting out a prediction about, hey, these are your top applications. But then, a disproportionate percentage were male, right? So essentially the algorithm was sexist. Of course, not sexist, not like the algorithm doesn't wake up in the morning and think, aha, how can I ruin women's lives? But that bias is like baked into the system. It's just like human implicit bias. It's a bias that you don't even know is there. It's real, it's there, but you're not even sure how it got in there or why it's there. So this is a huge problem. I'm not saying there's never a solution, but I do think it's going to require some really sophisticated statistics, and I think in many cases, we're still having difficulties figuring it out, as told by this example. I'm more skeptical about the non-representative problem, as I shared in another video. I do think there are actual solutions for that, but this is more of a wait and see kind of issue for me, and just speaks to the danger of using data that encapsulates the biases of society. It is dangerous. We should expect that when that kind of data is used, we're going to get algorithms that have some biases. It's like garbage in, garbage out. You put biased data in, you end up with an algorithm that's biased.